All right, Algebra 2. Today you're going to get a cheat sheet in the form of like a yellow bookmark type thing, and do not throw it away. It's what you're going to be able to use on quizzes and tests. I'm going to go ahead and show you the non-yellow version. This is the printed version right here. I'm going to be referencing this cheat sheet, and it's yellow in your hand. I'm going to be referencing this whenever I solve these equations. So this is from yesterday's assignment. Yesterday was April 9th. And I'm going to basically work out problem 4 with you. So with that said, buckle up, because this is going to be basically when someone's like, I don't know what I'm doing, I'm going to basically refer you to this video. So deal with it. And I hope you're having a good day. With that said, I'm going to go ahead and get into this gig. Here we go. I'm going to use blue today right now. I'll probably switch in a little bit. All right, the first things first. What we have to do on these problems is we have to figure out if there are any holes in this problem, if there's any vertical asymptotes, horizontal asymptotes, x-intercepts, y-intercepts, and then the domain. So there's a lot of stuff we have to know. It's a lot to memorize. Truth be told, I don't have most of this memorized. Oh, I have some of it memorized, but not all of it. And so this cheat sheet is going to be awesome. So we're going to go through it one at a time together. Yeah. That's it. Just make sure you know how to do. I was going to say something snarky, but I'm like, don't be a jerk. It's Wednesday. Let's just not be a jerk today. With that said, make sure you pay attention to how I do this. So let's go here. I'm going to start here, and my mind is going to blank out because I'm going to have a panic attack for no reason. And then what I'm going to do is I'm going to go ahead and try something else. Let me clear off this 3 so I have all this workspace for myself. So after our panic attack, let's go look at our little sheet right here. The first thing up here it says is factor first and cancel. Y'all, we did an entire unit on this, and we've done multiple units on factoring. So I'm going to go over here, and let's do that. Let's factor the numerator, and then let's factor the denominator. So how do I factor this thing right here? You basically have to do that ABC stuff. So let's do it. I have my A as 2. I have my B as -1, I have my C as -6, and I have my AC as 2 times -6, which is -12. Now, because my A is not 1, I'm going to have to do this the long way, which kind of stinks, but that's fine. It has to multiply to this and add to this. So using my factors, 1, 12, 2, 6, 3, 4. The only one I can get to that I can even see a relationship with is 3 and 4, because 4 minus 3 is 1, but now I got to do the right negative signs. So let's see. This number's negative, and this number's negative, which means one of these has to be negative. And then since this is negative, it means the bigger number needs to be negative. So I have 3 and -4. So my numbers are going to be 3 and -4. So how do I do this? Now what I'm going to do is I'm going to go ahead and I'm going to circle in purple my numbers, 3 and -4. And yes, I know that negative is misplaced. Deal with it. It's just life. Why am I going to write it in purple? Because I want you to see it. Here's my 2x squared. 2x squared. You ready for this next one? I'm going to move it to purple. Minus 4x. Minus 4x. I got that 4 right there, that -4. Then I'm going to have plus 3x. Plus 3x. And then I'm going to go ahead and go back to my blue. And then I have -6. This is something we've been doing since October. If you still can't do it, #bless. But go ahead and try to learn how to do this from here. So with that said, this is what it looks like. We have to check first. Does -4 plus 3 equal -1? The answer is yes. So we're probably on the right track. So now what we're going to do is we're going to go ahead and we're going to group this. And then once we group this, we're going to be stuck with GCF. So I look at this, I see a 2 and a 4. I know that a 2 goes into both of those. Then I see an x squared and an x to the 1. So I'm going to take out the smallest x and then reduce my x's by 1. 2 divided by 2 is 1, of course, and then 2 minus 1 is just x. So that's what happens here. And then -4 divided by 2 is -2, and then I remove that x from it. Awesome. Now I see 3 and 6. I know that I can take out a 3 in that. And since this number is positive, we're just going to make it positive. Any x's to take out? No, they don't both have x's, so here we go. I have x minus 2. So check out what we have here. I'm going to go ahead and underline now in black so you can see it. We have x minus 2 and x minus 2. So when we're done with our factors, I'm going to write this in black. It gets, there's the 2x plus 3. It's going to look like this. 2x plus 3 next to x minus 2. That's how I factored the top. So now the top is factored, and now let's look at the bottom. The bottom I can take a GCF out of. They don't both have x's, but I see that if I take the 3 out, something may happen, so I'm going to take the denominator over here and work it. So here it is. Here's this 3x squared minus 12. So my first step is I'm going to take the 3 out, but check out what happens when I do this. I end up with an x squared minus 4, y'all, which turns into 3x plus 2, x minus 2. This is called difference of squares. This is called difference of squares. Difference is subtraction. Minus sign, perfect square, it breaks down like this. We've done this quite a bit now at this point, and again, if you're struggling with this piece, I understand, but hashtag bless. With that said, 3 times x plus 2, and then x minus 2 goes here, right there. Very nice. So I have all this stuff right here. This is not a big deal. Now, I've factored first. I have now factored first. And now it wants me to, let me go to the sheet and see what it says. It wants me to cancel things out. The wholes, factor, and cancel out. All right, what does that mean? Well, I factored. Now I'm going to go ahead and cancel out. I'm going to switch to red for this to switch out this. So I have womp, womp. Look what I canceled out. I canceled out x minus 2. So I'm going to write x minus 2, and I'm going to set this equal to 0. And then when I solve it, I get x equals 2. So I have a hole at x equals 2. I have a hole at x equals 2, which is very interesting. 1 second, I need to push pause. Okay, so I'm back. So here's what's fun is I have x equals 2 for my hole. But here's the problem. I don't know this term. So what do you have to do here? Well, go to your simplified version. You have to go to your simplified version where the parts are crossed out. You can't use the original one. And you have to plug in your 2 for x. So what does that look like? I'm going to do it in red over here. So I'm going to start here. See how this x minus 2 is already gone? X minus 2 is already gone. We're going to plug it in here. So I'm going to say 2 times, and what am I plugging in? 2. And then here's that plus 3 right here. If you can't tell what I'm getting, it's up there. And then this one right here, I have 3 times 2 plus 2. So I'm going to work this out with you. 2 times 2 is 4, plus 3 is 7. And then I have 2 plus 2 inside, which is 4 times 3 is 12. So I found for my hole 7 over 12. That's what I found. That's how you do that. Pretty neat. Now that I've done that, what's going to happen next is my vertical asymptote. So I'm going to go ahead and switch to orange for this. I'm going to switch to orange for this. How do I solve my vertical asymptote? Well, if we have holes, which we do, then you basically have to use the one you factored out. You have to use this one because these holes are now removed, and we can basically find the remaining vertical asymptote. So let's go to our cheat sheet and see what it says. What does our cheat sheet say to do? It says vertical asymptote set denominator equal to 0. All right, let's do it. Set denominator equal to 0. I have moved to orange. So vertical asymptote is set denominator equal to 0, which is just 3 times x plus 2. I'm going to ignore that 3 because it's its own little thing. I'm just going to do the x plus 2 equal to 0. X plus 2 equal to 0, which gives me x equals negative 2. So my vertical asymptote is x equals negative 2. My horizontal asymptote, let's go to my cheat sheet and see what it says. My cheat sheet says, let's look at it. Where is it? Horizontal asymptote. The numerator is less than denominator. What are we talking about? The degrees. The degrees, y'all. So for degrees, we have to go to the original thing. I'm going to go and switch to purple. The degrees. Go to the original one. So the degree of the numerator, I'm going to write my numerator degree, and that is the largest exponent. It's the largest exponent, which is 2. And then my a value is the number attached to the exponent. So here's my 2 right here. That goes in the degree. And then this number right here is my a. Then I need to know the denominator degree. The denominator degree. And in this case, it is also 2. So then my b is the number attached to the exponent right here, the coefficient, and that is 3. So let's go see what happens on our cheat sheet. When it says the numerator is equal to denominator, you go y equals a over b. Y equals a over b, which is great. Why is this thing blinking? Whatever. Y equals a over b. So do I have an a? I certainly do, right there. Do I have a b? I certainly do. So I'm going to just go ahead and do it. So it says y equals a over b, which doesn't help much, but then I put in the numbers, and I get 2 over 3. So I have, for my horizontal asymptote, y equals 2 over 3. X-intercept. What's the rule for x-intercept? Set numerator equal to 0. Set numerator equal to 0. Do not use the canceled term. Do not use the canceled term. Meaning you're not going to, like, you're going to use this one right here. You're going to basically use, oops, falling out of line here. You're going to basically use this. So once you have a cancellation in there, you're not going to use it to solve for certain pieces. You're going to ignore that cancellation part. So it wants you to find the x-intercept by setting the numerator equal to 0. So the numerator equal to 0, here we go, is I'm going to switch to what color now? I'll go to black. The x-intercept is 2x plus 3. 2x plus 3, setting equal to 0. This is my numerator. So I'm going to move my negative 3 over. I subtract 3 on both sides, and I end up with 2x equals negative 3. I divide the 2 out, and I get x equals negative 3 over 2. So for my intercept right here, I get negative 3 over 2, which is great. My y-intercept now, let's go to my cheat sheet and see what it says to do. My y-intercept, it says let x equal 0 and solve. That means you plug in 0 and solve. You plug in 0 and solve. So you go to the original thing and you basically plug in 0 and solve this out. That's how you do it. So now what I'm going to do is I'm going to switch to green for this one. Sorry for the mess. Y'all know how I work. I'm going to plug in 0 for this. You ready? So here it comes for y-intercept. So y-int, plug in 0. What does that look like? Go to the original. 2 times 0 squared minus 0 minus 6 over 3 times 0 squared minus 12. So 2 times 0 is 0, minus 0 is 0, minus 6. So I have a minus 6 up here over 3 blah, blah, blah. That turns to 0. Minus 12 is what I have left over here. The negatives cancel out, and this reduces down to 1/2. So I found my y-intercept on this problem to be 1/2. Found my y-intercept to be 1/2. Now, for domain and range, it's very simple. We're going to go over here and check our cheat sheet. Our cheat sheet says the domain is all reals except where there are holes and except where there's the vertical asymptote. So it's all reals except where there are holes and vertical asymptotes. So I'm going to use yellow. Does yellow show up? Oh, not really. I'll switch to red. So we're going to use all reals, that weird R thing that I'm terrible at drawing. Welcome to my art skills. All reals, except it can't be vertical asymptotes and it can't be holes. So what do I have here? Why can't I move this up? All right, work. Okay, here we go. Vertical asymptote is -2 and then a hole at 2. So do you see those numbers up there? It's 2 and -2. I can't use that. So I can use all real numbers except x can't equal 2, x can't equal 2, and x cannot equal -2. The range is, let me looking on this, the range is going to the cheat sheet. Everything, but it can't accept any y holes, not the y of the hole. What do I mean by that? Well, check it out. What's the y of the hole? It's 7/12. You see that y right there? It's 7/12. So y can't equal 7/12. Y can't equal 7/12. And y also can't equal the horizontal asymptote, which is 2/3. 2/3. And then that is it. Is that a lot? Yeah. Is it that difficult if you break it down piece by piece? No. Is it slow? Yes. So that's it. That's the mess. That's the work. That's your full answer. This is how you do every problem. This is a good example of what is required to get this done. So this is it. I'm going to be referring y'all to this video over and over again because I don't want to explain this 1,000 times. So with that said, that's enough work for today. I'm done with it.